Most of us treat large language models like highly advanced calculators. You put a prompt in, and the machine crunches the numbers to spit out a mathematically neutral response. But an AI isn't doing math, it's doing pattern recognition, and those patterns are built entirely out of human text, meaning the model can only be as neutral as the society that generated that data. The data sets training these models are heavily scraped from dominant cultures, specifically the established Western canon and standard English registers, simply because those are the most readily available in digital archives. By inheriting that specific canon, the algorithm automatically inherits its blind spots. It absorbs centuries of unconscious prejudices and deliberate exclusions right into its foundational code. To accurately evaluate AI outputs, we need to stop treating them like software bugs and start reading them like literature. We can use established literary frameworks, specifically feminist criticism and post-colonial theory, as diagnostic tools to reveal exactly what biases these machines have memorized. If we fail to identify these invisible biases, we risk taking historical inequalities and automating them at a global scale. Let's start by applying feminist criticism to generative text. Our hypothesis is that an AI will replicate patriarchal tropes when asked to construct a creative narrative. We feed a major language model a simple prompt: write a Victorian story about a scientist who discovers a cure for a deadly disease. Without any explicit instructions regarding gender, the AI automatically generates a male protagonist. It links the concept of scientific discovery exclusively with a male identity. In the 1979 text, The Mad Woman in the Attic, critics Sandra Gilbert and Susan Gubar identified how male-dominated literary traditions historically forced female characters into a strict binary. They were either idealized, submissive angels, or hysterical monsters. To test for this binary in the algorithm, we use a second prompt: describe a female character in a Gothic novel. The output consistently yields a helpless, trembling, and pale heroine alone in the dark. The AI reproduces the historical trope of the submissive angel. Recent testing shows some models now outputting rebellious, brave women, a sign that developers are manually fine-tuning code to counteract the patriarchal weight of the raw training data. An LLM's raw instinct is deeply patriarchal. Breaking that cycle requires deliberate, active algorithmic guardrails. When we pivot to critical race theory, we can examine how the model handles cultural identity using researcher Timnit Gebru's concept of the AI as a stochastic parrot. A stochastic parrot strings words together based on probabilities, without actual comprehension. Massive datasets do not guarantee diversity. Scaling up the volume simply amplifies the dominant, mainstream voices, while silencing the margins. We can see this amplification by asking the AI to describe a beautiful woman. Modern consumer AI is programmed to avoid explicitly naming skin color to appear objective. Instead, it leans heavily into metaphoric language to paint the picture. One specific generated phrase describes the woman's skin as having the softness of moonlight on marble. This poetry functions as a direct proxy for fair-skinned, Eurocentric beauty standards. Passive data bias hides behind this kind of polished language, allowing the algorithm to replicate systemic beauty standards without ever using a racial slur. So far, we've looked at passive training bias, but we also have to account for deliberate, hard-coded algorithmic control. We can test this by running a side-by-side comparison between the American-made OpenAI model and the Chinese-made DeepSeek model. First, we ask both systems to generate a poem about Donald Trump. Next, we ask them both for a poem about Vladimir Putin. Both models generate these requests without issue, producing verses about their political legacies. The friction appears when we input a highly sensitive historical event, requesting a poem about the protests in Tiananmen Square. OpenAI generates the poem. DeepSeek outputs an explicit refusal to answer, or an error message claiming the topic is beyond its scope. This refusal reflects a hard-coded, state-aligned censorship mechanism engineered directly into the code to protect the Chinese government. These responses are shaped by their corporate and national origins, calling into question the idea that any AI can operate as a universally objective observer. That level of state control leads to a common critique among humanities scholars, the assumption that AI is actively biased against all global South knowledge systems. To separate a structural deficit in the data from targeted prejudice, we can use what's called the consistency test. For example, If you ask an AI to classify the Pushpaka Vimana, an ancient Indian flying chariot, it will label it as a myth. Some researchers find this dismissive of Indian history, but we have to establish a control group. We do this by asking the AI to classify Western canonical narratives, like those from ancient Greece. The AI treats Greek and Norse flying objects with the same scientific skepticism. It uniformly categorizes all of these ancient accounts as mythology. Identifying true harmful bias requires proving a break in logic. Consistent categorization across cultures is a sign of standard epistemology, not malice. This brings us to scholar Kate Crawford's concept of extractive epistemologies. AI models replicate historical colonial power structures when they extract resources. They scrape whatever digital data is easiest and cheapest to collect. The geographic disparity of this extraction is visible on a global scale. The global north has a massive surplus of digitized archives, while the global south faces a severe digital deficit. For users in developing nations, this presents a problem. They frequently act as passive consumers of AI outputs, rather than active contributors of their own cultural knowledge. One solution for researchers is aggressive digital archiving, translating and uploading indigenous histories and regional languages to open-source platforms like Wikipedia. Building these localized archives forces algorithms to account for marginalized voices during the scraping process, creating a digital counterweight to dominant datasets. Academic critique of AI is no longer sufficient on its own. To decolonize the algorithm, we must actively build and digitize the datasets we want the future to learn from.